Hello dear student, I am Manoj Islam. Today in this video I will discuss important question of IIT PhD interview, and this question from interview of IIT Bhubaneswar. Okay, so let's start. Question one. So just a minute. Question one. We will discuss three questions here. Okay. So first question. First question was this question was asked by Alu sir. This question was this: suppose FZ compressible function, which suppose is power series function like this: n equal to 0 to infinity n z to n, means this power series about z equal to 0. Okay, and it is given this power series is converges on real line, means this power series converges on, if it x axis, if it y axis, this power series converges only this portion 0 to infinity, converges on only the ray. Okay, 0 to infinity, only this ray. This power series converges on only this ray, converges on 0 to infinity. Okay, then what can you say about this function? This function is entire, this function entire or meromorphic, or such a function not exist. Okay. What can it is given that fz is a function with power series represented by this n equal to 0 to infinity n z minus 0 whole power n. Okay, this and given is power series converges, this power series converges only the ray, this ray 0 to infinity, 0 to infinity is open interval. Okay, then what can you say about this function? This function is entire, meromorphic, or such a function not exist. Okay, so let's say solution. Say it is given that fz is equal to, is power series like this, summation n equal to 0 to infinity n z minus 0 whole power n. Okay, this power series about z0 equal to 0, and it converges on real line on 0 to infinity open interval. Okay, suppose it radius convergence, I am assuming that it radius convergence r, it ROC radius convergence. Okay, then it means this power series will converge absolutely, this power series will converge absolutely on this circle z minus 0 less than r. Okay, within this region this power series should converge absolutely, and outside this will diverge. Okay, so if you try to draw this, so x-axis, so your y-axis. Okay, and it is given it power series converges on 0 infinity this ray. Okay, this ray, this power series converges on this ray. Okay, now I am assuming it radius converges r, and r suppose greater 0. Okay, then it is obvious from definition of radius convergence that this power series will converge in 0 if I draw a circle on 0 center and r radius, suppose r is here. Okay, so if I draw a circle this, within this series, this circle, the power series converges absolutely. Okay, interior of this circle, in this circle the power series converges absolutely converges. Okay, see given that converges only at this point, this is on the ray line point. Okay, is given that the power series converges, but using the idea of idea of radius convergence, I have This idea of radius convergence, you can tell that the power series convergence also this person also, this person also, this person also, this person also. Okay, so the power series convergence, the point is in the line also. Okay, using the idea of radius of convergence, you can say. Okay, similarly you can do 2r. Okay, because it is given that it is radius convergence, given that it's convergence on this line. Okay, so it radius convergence maybe 2r. Okay, so you can again draw a circle like this. Okay, in this power is also converges absolutely. Okay, similarly you can extend this radius convergence, then you can make a more larger circle. Okay, more larger circle, and from definition of radius convergence you can tell in this circle this function converges absolutely. Okay, so like this, if you draw circle and extend the radius convergence, this you can easily understand that this circle covers the whole complex plane. This circle will cover the whole complex plane. So the function will be this power series will converge on the whole complex plane. Okay, the power series will converge on whole complex plane. So you can say fz function n equal to 0 to infinity, this power series a n z minus 0 to 1, this converge on whole complex plane. This means modular less than infinity. This implies the function fz will entire. Okay, so if a function of the form if this function is equal to n z to n, this converges only on real ray line 0 to infinity this ray. Okay, then you can say from here, using the idea of difference convergence is the idea of radius convergence, that this function is entire. It will converge everywhere on the complex plane, and this gives the function is entire. Okay, this is very nice question. This question was asked in IIT Bhubaneswar interview by Alu sir. Okay, so it is first question, so it will be entire function. Now we are going to discuss one more question. Same question. Same this. It is given that it is known question. Fz function is entire. Okay, it is entire function, and it is given that this function fz is analytic also at z equal to infinity. At z equal to infinity means z equal to infinity, the function is also analytic. The function is analytic. Its entire function means fz is analytic within on finite complex plane. Within finite complex plane, the function is analytic. Okay. Also, it is given that it is analytic or zero infinity. Then what can we say about this function? Then question is what can we say about this function? What can we say about this function? Okay. The question is given that the function is entire function and also analytic at zero infinity. Analytic at zero infinity. Then what can we say about this function? Say it is entire function. The function is entire, so you can extend the power series. You can write the power series at z equal to 0. So you can write the summation n 0 to n z minus 0 whole to n. Okay. Now it is also given this function fz is analytic at z equal to infinity. This is analytic at z equal to infinity also. Okay. So I am putting z equal to 1 by w. So this gives summation n equal to 0 to infinity in 1 by w to n. Okay. You can write like this, summation a0 plus a1 by w, a2 by w square, so on. Okay. Now since we know this fz is analytic at 0 to infinity, fz is analytic at 0 to infinity, so f of 1 by w is analytic at w equal to 0. Okay, since fz is analytic at z equal to infinity, so this is imply f of 1 by w, this is also analytic at w equal to 0. So this function f of w 1 by w is analytic at w equal to 0. So it's obvious that this coefficient a1 should be 0, this a2 should be 0, because if a1 not 0, suppose a0 and a1 are non-zero, then and all are 0, then this gives f of 1 w has 4 of order 1. If a1 if n all are non-zero, then this gives f1 by w has essential singularity, okay, and w equal to 0. This function will have essential singularity and w equal to 0. So this is also not possible because this is an analytic function. So a1 should be 0, a2 should be 0, and all coefficient except a0 should be 0. Okay, so from here you can tell that a1 should be 0, a2 should be 0, and all coefficient you can say an for 0 for n greater than equal to 2. So if n equal to 0 for n greater than 2, and if you place here if you place here the value of n, then so this will be left n only, because a2 0, a3 0, a4 0, and all 0, so this is left n only, and this is a constant, so fz will be a constant function. So I can say that if fz is an integer function and n equals to 0 infinity, then the function is constant itself. Such a function is constant itself. Okay, so these two are questions from complex analysis, and one more question also asked from function analysis, so I am writing that question. Third question, this question from function analysis. Okay. This question is, every non-linear space induce a metric space. Okay, but what is true? Metric space induce every metric space a non-linear space? This is a question. Every non-linear space induce a metric space, we all know this, but every metric space is a non-linear space? This is a question. Okay. We all know, if suppose x be the D be the metric space, x D be the metric space, okay, and D is mapping from x cross x to R, suppose, then dxy equal to norm x minus y for x comma y belongs to x, then this induce a metric. Okay, this norm induce a metric. We all know this norm induce is a metric on x. Okay, but it reverse is not true. It means every non-linear space is a metric space. Every non-linear space is a metric space. Every non-linear space is a metric space. Okay, but reverse is not true. Every metric space is not a non-linear space. And there are so many examples. Okay, I am writing two examples here. First example. I am taking x equal to r, set of real number. Okay, then I define D from R cross R to R plus set of positive real number. R plus means set of all positive real number. Those x belongs to real number such that x greater 0. Okay, and I define dxy by dxy equal to mod of e to power x minus e to power y. Okay, mod of e to power x minus e to power y, where x y belongs to R. Then clearly you can check this is a metric. Okay, this will be metric. Okay, you can easily check this will be metric. dxy equal to mod of e to power x minus e to y, this will be greater than 0. Okay, for xy belongs to R, and if dxy equal to 0, dxy 0, if only this gives e to power x minus e to power y will be 0, and e to power x minus 0 will be mod 0 means e to power x mod e to power mod this minus this will be 0. Mod of a real number 0 means the real number is itself 0. Okay, so this mod is 0, so the real number will be itself 0. E to power x minus e to power x will be 0. Now e to power x minus e to power x will be 0, so this gives e to power x equal to e to power y. Now e to power x equal to e to power y, this gives x equal to y. So dxy equal to 0 if you leave x equal to y. So this, so positiveness m1 hold. So you can say m1 holds. Okay, now m2 symmetry is trivial. Okay, d of yx, this gives according to definition d e to power y e to power x, so you can write like this, e to power mod of e to power x minus e to power y, so this is dxy. So dxy equal to dyx, dxy equal to dx for x x. Okay, so m2 also holds. Now m3 means triangularity. For all x, y, z belongs to R equal to x, you can write like this, dxz equal to e to power x minus e to power z. You can write like e to power x minus e to power y, just e to power y minus e to power z. Okay, So if you apply triangle to real numbers mod, so this gives mod of e to power x minus e to power y plus e to power y minus e to power z. Okay, so this gives dxy plus dyz. Okay, so from here you got triangle inequality, so m3 also hold. So from here you can say x comma d with x is r is a matrix space. Okay, so x comma d where x is a real set of real number, d defined by dxy equal to e to power x minus e to power y. This is a matrix space. Okay, this is a matrix space. But this matrix space never induces a norm. Okay, suppose if it induces norm, then norm. So in this is norm, then this part satisfies norm of lambda is equal to mod lambda into norm x. Okay, for scalar lambda belongs to f and for x belongs to r. This part will be must satisfied. Okay, this is second part of norm. Okay, if it's norm, then this part must be satisfied, but in this part is not satisfied by this metric. Okay, you can easily check it. How can you check it? If you want to compute this d of lambda is lambda y, so this gives e to power lambda s minus e to power lambda. Okay, is never equal to mod lambda equal into e to power x minus e to power y. Okay, so not equal to mod lambda dxy. Okay, so this part is not following with this metric, so this is not a nonlinear space. So this is an example of a metric space but is not a nonlinear space. Okay, so every nonlinear space is a metric space. Every nonlinear space is a metric space, but reverse is not true. Every metric space not induce a norm. This is a metric space which not induce a norm. Also, there are one more example you can take. Okay, I am writing that example also. So S is a sequence, a set of all sequences xn. So that you can take real sequences xn, so that xn belongs to R. Okay, and I am defining dxy dxn comma yn equal to summation n equal to 1 to infinity 1 upon 2 power n mod xn minus yn 1 plus mod xn yn. Okay, we all know this is metric space. Okay, no need to do this. We all know this is metric space. Okay, this metric space is called Frechet metric. S comma d is a metric space. Okay, this I think is called Frechet matrix. Frechet matrix space. Okay, but it is not a, it's metric space, but it is not a nonlinear space. Similar reason why you can, if you want to compute this mod d of lambda is lambda n, so this gives summation n equal to 1 to infinity 1 upon 2 to n. Okay, mod of lambda xn lambda yn 1 plus lambda xn lambda yn. From here you can not get mod lambda outside. Okay, here mod lambda will be outside in case, but here you can take never common mod lambda. Okay, so this is not mod lambda into dx and yn. Okay, so it is not following the second property also. So s comma d is a metric space, but phase metric, but it is not a nonlinear space. So these are three questions that are asked in IIT Bhubaneswar. Okay, so please follow my channel and I will give more video regarding this. Okay, so thank you.